You are welcome to this YouTube channel, Edisam Academy. And if you are a new viewer here, if you are new here, please consider to subscribe to this channel so that you'll be updated on any videos that we usually upload every single week. All right. So today we'll be looking at ID gas and real gas. Actually, the major topic, the major emphasis is what? ID gas law. And of course, in this ID gas law, we also consider real gases. So we are looking at ID gas and what? And real gas. All right. So looking at my left hand side, these are the objectives we are going to cover for today. Of course, we'll start with the introduction. We introduce ID gas, what they are, and then from there we look at ID gas equation. Yeah. So we'll look at the derivation, of course, we'll look at the parameters that are involved, and from there we'll look at the differences between ID gas and real gas, which is where people usually mistaking it. And of course, if you follow this YouTube channel, you notice that yes, that we are going to explain all these concepts, these complex concepts to your own understanding. So just follow suit, particularly this one, usually come out in jam questions. So it's very important. So we'll differentiate it. And the same thing with this one, deviation of real gas from ID gas. In fact, you see this 1, 2, and then the equation. These three, the ID gas equation, the differences and the deviation, they are the parts that they usually ask questions. Are we together now? But just relax your mind. Provided you follow me to the end, you are going to enjoy this video, and not just that, you are able to what? To solve real problems as regards to what? To this topic. Then we second to the last, we look at the limitation of the ID gas. Many people don't know this, but of course we are going to look at it. And then lastly, we'll solve examples. And if you are here and you are preparing for JAM 2026, this topic is very important. It's very important because in gas laws, this is one of the gas law. ID gas equation is one of the gas law. All right. So let's dive into what we have for today. Introduction. Now, what are ID gas? What are ID gas? Of course, you should, your basic knowledge of gas. We have the three states of matter. We have the liquid, the solid, and the gas. And gas, is a very important component of anything you are going to even do as a chemistry student. You will come across it in your theory. You will come across it in your practicals. You understand? So when we do test of ions and all of that, we test for certain gases as well. All right. So gas, according to the state of matter, it has certain characteristics. And one of the characteristics is that it expands to fill the shape of its container. Unlike solid that has a fixed shape, liquid that occupy the shape of the particular container it is put in, and for gas, it fills the container entirely. It fills the container. So when it comes to ID gas, the ID gas here, ideal from the word, when we extract the first 4 letters, that is idea. Are we together now? So idea, that means something that is within the realm of imagination. Is that clear now? So idea is fictional. Something that is fictional is not real. It is theoretical, or we can say hypothetical. Are we together now? So when we say ideal, it's from the word idea, something that is not real. Is that clear now? It is imaginative. It is at the realm of idea. Now, when we say ID gas now, ID gas, our gas that an ID gas is a gas that is not real. Is that clear now? It's a gas that is what? That is not real. So in terms of definition, you will say that ID gas is a theoretical or hypothetical gas that obeys the condition of that obeys all the condition of temperature and pressure. That is what ID gas is. Is a gas, is a theoretical gas, or is a hypothetical gas that obeys all the condition of temperature and pressure. And what are the conditions of temperature and pressure? It can be high temperature, it can be low temperature, it can be high pressure, it can be low pressure. Are we together now? All right. So aside ID gas being that is obeying all the conditions of temperature and pressure, another definition for ID gas is that is a gas that what? Is a gas that obeys the gas law. Yes, just follow me carefully. I'm going to explain all these things in details. So it's a gas that what? That obey gas law. All right. So having said that, now your question will now be, what are the gas law? What are the gas law? Of course, we have the gas laws. Includes the first one is what? Is Boyle law. Sorry, let me mistake here. Boyle's law. We have Charles law. We have Charles law. We have yes, Gay-Lussac's law. Gay-Lussac's law. And we also have Avogadro's law. Avogadro's law. Yes, we have Graham's law as well, but I'm not going to include that for now because of the emphasis we are making here. Is that clear now? Basically, these are the laws that ID gas obey. So that is why we said ID gas is a gas that obeys the gas law. So they follow the characteristics of this gas law. That is what ID gas is. And of course, you can also define it as well as a theoretical gas that obey all the condition of temperature and pressure. Is that clear now? Now, from our basic understanding of what Boyle's law is, you remember that Boyle's law states that the volume of a given mass of a gas, are we together, is inversely proportional to what? To its pressure at constant temperature. So in Boyle's law, temperature is what? Is constant. Is that clear? Now, in Charles' law, it states that the volume of a given mass of a gas is what? Directly proportional to its what? To its temperature. Is that clear? So, provided that pressure remains constant. So, in Boyle's law, temperature remains constant. In Charles' law, pressure remains constant. All right. Now, how about Graham's law? In Graham's law, if here temperature remains constant, here pressure remains constant, what do you think will remain constant here? All right, just put that in the comment section. Let's see who will get it. So in Gay-Lussac's law, volume will remain constant. So how do I state Gay-Lussac's law? Gay-Lussac's law states that the pressure, just follow me carefully, the pressure of a given mass of a gas is directly proportional to its what? To its temperature, provided volume remains constant. Is that clear now? All right. So now, how about Avogadro's law? Many people have challenge in this Avogadro's law, but that is not a problem. Of course, I'm still going to do a full video on the calculation. I will do video on these two, Gay-Lussac's law and Avogadro's law, because they still have an extension. This one has Gay-Lussac's laws of combining volume, which is very important. They usually, ask it in jam questions. So I'm going to deal with this Gay-Lussac's law of combining volume later in the video. That's why you need to subscribe to this YouTube channel so that you don't miss out in any informative videos that I'll be uploading later on. All right. So of course you should like and also subscribe, share to your colleagues, your friends that are preparing for this JAM 2022, and you see that you come back and testify of this wonderful videos. All right. So now in Avogadro's law talks about, it adds another parameter, which is the number of mole. Are we together now? So Avogadro's law states that equal volume of all gases at the same temperature and pressure contain the same number of mole. Yes, contains the same number of mole. Are we together now? So this one brings in a different parameter, which is what? Which is our N. Is that clear now? So this N now, of course, we are going to link everything together, but majorly in forming, okay, I've entered ID gas equation now, because we are going to use this to derive the equation. Is that clear now? All right. So yes. So here we are going to combine all the parameters, and that is where we now have our what? How we are going to generate our what? ID gas equation. Is that clear? Some people do call it ID gas law, ID gas equation. When you talk about the equation is the one that combines the parameters, the gas law that combines them together. But when you say the ID gas law is just like a general law, that the overview of the law. Is that clear now? All right. So ID gas equation is just a single equation that combines all the ID gas laws. Do you understand now? All right. Just follow me carefully. So now, how do we derive this ID gas equation? Good. Now, so when you want to derive this ID gas equation, just pardon me. Let me clean this aspect. All right, so we have our Boyle's law. We start from the Boyle's law. Now, we have our Boyle's law to be what? To be V, that inversely proportional to what? 1 over P, isn't it? Now, Charles' law is directly proportional to what? To T. Is that clear? So, we can know, so we will add it. So, it is inverse, so volume is inversely proportional to what? To P, and directly proportional to what? To T. Are we together? Which is also what? Now, please listen carefully here now. You will notice that in these two equations, we already have our pressure, isn't it? We already have our temperature here. And this Gay-Lussac's law here combines the two. So we are going to omit it. Do you understand? Because the parameter, the pressure and temperature here are already found in the first two equations. So what I will do is that I will have to what? Jump to this one. Okay, sorry, I didn't complete this initially. Here, Avogadro's law states that that is V is directly proportional to N. Yes, that is the full equation. I only wrote N. Sorry. So it's V directly proportional to what? To N. Is that clear now? So I will omit this because the pressure and the temperature here is already found in the two equations. You get the point now? All right. So I will now say is also directly proportional to what? To N. To N. You get that now? So V, this. Is that clear now? Now, if you notice, you will see that there is a proportionality sign at each of these. There is a proportionality sign. So V is inversely proportional to this. V is directly proportional to T. V is directly proportional to N. But mind you, whenever you say inversely, you are putting 1 over the parameter. Because Charles' law is directly proportional to T, so I don't need to put 1 over T. Do you understand? So it is also directly proportional to N, which is the number of mole amount. So it is what? V directly proportional to N. So I don't need to put 1 over N. But you see Boyle's law that is inversely, just like when you say 1 over 2. What is the inverse of 1 over 2 is what? 2 over 1. Do you understand now? So the representation of an inverse proportion is when you put 1 over the parameters of that thing you are talking about. Is that clear now? All right. Now, if we see any proportionality sign like this, what do we usually introduce to eliminate the proportionality sign? What do we usually introduce here? We introduce what? A constant. And when we introduce a constant, this proportionality sign will be changed to equal to. Is that clear? All right. So let's now introduce a proportionality sign. And in ideal gas equation, there's usually a proportionality constant that we use, which is what? Which is R. Which is R. Now, in general gas equation, we introduce the proportionality constant of K. You remember, we introduced K as constant. But in this ideal gas equation, in this ideal gas law, we introduce R as our constant. And what is our R? R is universal gravitational constant. Yes, universal gravitational constant. That is for R. That is the constant R. All right. So now let's now introduce the proportionality constant. We have V equals to R multiplied by 1 over P multiplied by T multiplied by what? N. Is that clear now? Are we together? All right, because this V can be equals to what? R times T. This V can equals to what? R times N. That is introducing the constant. V can equals to what? R times this, because this is for Boyle's law, this is for Charles' law, this is for what? Avogadro's law. All right. So now, if we add everything together, we have R, of course, R times 1 times T times N over what? Over P. So we have, let me take it one after. 1 over P times what? N T. So if you consider, so I'm just taking it step by step so that you follow it very well. So we have N, this now. N R T over what? Over P. Now, what do you do from here? You cross multiply, isn't it? So when we cross multiply, let's say this is over invisible 1. All right. So we cross multiply to have PV equals to what? 1 times nRT equals to nRT. This is our ideal gas equation. Ideal gas equation. Ideal gas equation. Yes, this is our what? Ideal gas equation. So what is our P? Our P is what? Pressure. What is our V? Our V is volume. N is in what? Number of mole or amount in mole. This is R is our constant, which is universal gravitational constant. Then T is our what? Temperature. You see that we've been able to what? To compress, to add all of the what? The gas laws into one equation called ideal gas equation. So we've done this. We've done this. We've done this. Now let's go to the differences between ideal gas and what? And real gas. This is very important. This is very important. All right. Of course, in these sub examples, we also look at some questions that can come under this equation, where you use this equation to solve examples. All right. So to differentiate between ideal gas and what? And real gas. Now, okay, let me clean this so that I have a football. All right, so we have ideal gas. Now, ideal gas, then real gas. I've explained this ideal gas that they are theoretical, that is, they are hypothetical, they are not real. From the word idea, we have ideal. Is that clear now? So they are not real. Is that clear? They are not real gases. They don't exist in reality. Is that clear? So my first difference is in terms of what? Existence. Existence. So they are not real. That is not real. Are we together? But here they are what? They are what? They are real. Is that clear? So here they are what? They are real. Example of this real gas is what? Hydrogen gas. Yes. Nitrogen gas. Of course, they are found in the atmosphere. We have CO2. And we also have noble gas. Yes. If you check in the periodic table, the group 7 elements are the halogens. The group 8, they are the noble gases. Do you understand? So we include them noble gases. Yes, argon is there, neon is there, of course. So they are examples of what? Of real gases. Are we together? Because they are real. They are what? They are real. Now let's look at another example in terms of what? In terms of volume. Ideal gas, they don't have volume. No volume. But this now, they have what? They have volume. Yes, they have volume. The second one, the third difference is in terms of their intermolecular force. Intermolecular force. In terms of intermolecular force, this ideal gas no intermolecular force. But you see real gas, they have presence of what? Intermolecular force. I'm taking my time to put them down so that in your own end, you will put them down in order for easy explanation, if at all there is a need to explain to someone. That is why I'm taking my time to put it down this way for easy understanding. All right. Now, another difference is their what? Is the elasticity. Elasticity, yes. In terms of elasticity, ideal gas are what? Are perfectly elastic, yes. Perfectly elastic. But this one, perfectly inelastic. Perfectly inelastic. Now, that is their. Now, let me explain something here. When something is perfectly elastic or perfectly inelastic, Now, one of the theory of gases, okay, I didn't include that here, but I'm going to include that in my next video where I will be solving calculations based on the gas laws. That is when I'll put it. That one is kinetic theory of gases. One of the kinetic theory of gases is that the gas particles, they move in what? In random motion. They move constantly in what? In random motion. And as they move, they collide with themselves and they collide with the walls of their container. Are we together now? So when they collide, their collision is what? Is perfectly what? Elastic. That is, what it means is that there is no net change. There is no energy lost, or there is no what? Energy gain. Good. So that is what we mean by what? Perfectly elastic. Perfectly elastic. All right. So that is all about that. If there is more differences, you can put that in the comment section. Thank you. Oh, okay. Okay. No. There is one. Yes, I just remembered. There is one that is important. There is one that is important that you need to know, and that is okay. That is the deviation. Yes, deviation of gas, of real gas from what? Ideal gas. Real gas and ideal gas. Now, okay, I will input it here, but I'm already explaining this already. So I will input it here. I will input it. I'm explaining deviation of deviation of real gas from what? Ideal gas. So I will include it in the differences as well, so that it will be easy for you. All right. So what is the deviation of what? Real gas from ideal gas. Remember when I started this video, I said when I was introducing what ideal gas is, I said that ideal gas, they are what? They obey the condition of temperature and what? And gases. And pressure. At all condition of temperature and pressure, ideal gas obey it. Both high temperature, low temperature, high pressure, low pressure. Do you understand? So in terms of deviation, this one, all conditions of temperature and pressure. You understand? But in the case of real gas deviates from real gas deviates from ideal gas at what? At high pressure and low temperature. Yes, they deviate from real gas deviate from ideal gas at high pressure and low temperature. So they behave like ideal at low pressure, high temperature. That is the opposite now. So each time they deviate from ideal gas, that means that at that particular time, they have high pressure. The pressure is high and the temperature is what? Is low. But each time they want to behave ideally, they usually ask that question. They say, at what condition or at what temperature or at what pressure do real gas behave ideally? Do you understand? So the condition at which real gas behave like ideal gas is what? Is at low pressure. At high pressure, they deviate from them. They don't behave ideally. But at low pressure, they behave like ideal gas. Do you understand now? They behave like ideal gas at low pressure. Low pressure, high temperature. They behave like ideal gas. But they deviate from ideal gas at high pressure, low temperature. It can be very confusing. But okay, I think I should put that. Deviation at high pressure and low pressure, but behave ideally like ideal gas at low pressure now. Low pressure and high temperature. So you see that now. So that is what? That is the deviation. That is the part. That is the time that they deviate. they deviate at high pressure and low temperature. They now behave like ID gas at low pressure and what? And high temperature. All right. So how about the limitation of what? Of ID gas. How about the limitation of ID gas? I think I will also include it here. We'll also include it here. The limitation of ID gas is that it does not liquefy, which can also be, which can as well be put under the differences. Do you understand? So I'm just creating this table so that you grab the full information about ID gas and real gas. Do you understand now? So in terms of what? So in terms of the limitation, so let me just include it here. In terms of what? Limitation. So limitation. ID gas, they do not liquefy. Do not liquefy. They do not liquefy. Are we together? But for real gas, they do liquefy. Yes, they can liquefy. Yes, and that is if you study oxygen and nitrogen and their compounds, you will notice that one of their preparation is actually liquefaction of air. When you first liquefy it, that is, you turn the air to liquid. Then you now pass it through. You now take it through fractional distillation. Is a preparation of what? Of this oxygen and nitrogen. Yes, liquefaction of air. So that is why they are real gases. Real gases can liquefy. Is that clear? But ideal gas, because they are not real, so they cannot liquefy. They do not liquefy. Is that clear? So they do not liquefy. And of course, these ones, they are not real. Why these ones too? They are what? They are real. All right. So now for solved examples, all right. So just get this one. And if you have any question, please drop them in the comment section. Drop them in the comment section and we'll attend to it. Is that clear? Drop them in the what? In the comment section. Thank you so much for watching to this point, and I believe you have a full grasp of what we did today. ID gas and what? And real gas. Please subscribe to this YouTube channel, Edusam Academy. Subscribe to this YouTube channel. We are ready to serve you, to break down complex, topics, for you. Yes, that is why we are here. So like, comment, let us know in the comment section if you really enjoyed this video, and if you have any question, you can just drop them in the comment section. So like, share, and subscribe to this and turn on the notification bell so that you not miss out on our upload. Yeah, all right. So thank you.